Agrivoltaics. Agrivoltaics is all about pairing solar power with agriculture, so you're not just putting panels on a field, you're combining energy production with space for crops, grazing, and even native habitats under and between the panels. The U.S. National Renewable Energy Laboratory, NREL, studies how these systems actually perform and what trade-offs there are between food production, energy generation, and ecological impacts. One of the big ideas behind agrivoltaics is that when you meet renewable energy goals by building large solar arrays, you might otherwise take land out of food production. But agrivoltaics offers a way to balance food and energy goals, and in the right conditions, both crops and solar power can do better together than they do apart. These systems can also provide unexpected economic and ecological benefits that aren't typically found in traditional solar developments. Agrivoltaics isn't always more expensive than conventional solar, but certain project designs can be more complex to plan and permit. To make a project work, you often need both farmers or land managers and solar developers to collaborate because their priorities can be quite different. NREL helps by doing research and analysis that documents both the benefits and costs, and by bringing together local stakeholders and developers so they can find solutions that work for everyone and scale up best practices. There are a bunch of benefits associated with agrivoltaics. For example, keeping more of the ecosystem intact, rather than clearing and grading the land, can help maintain soil health and water quality, and can even create habitat for pollinators and other beneficial insects. Using different ground covers and low-impact design approaches can make solar sites more permeable and reduce stormwater runoff, which is a key consideration for permitting. When it comes to crops, many kinds have been shown to thrive under partial shade from solar panels. The shade changes the microclimate. It can be cooler in the day, warmer at night, and help retain more soil moisture. In some dry regions, this means crops can even yield more with less irrigation. In wetter areas, spacing and panel layout become important to manage water properly. Agrivoltaics isn't limited to crops. Livestock grazing is another application, where animals like sheep can graze beneath panels and help manage vegetation without the need for mechanical trimming or herbicides, and the animals enjoy shade from the solar arrays. NREL highlights what agrivoltaics looks like in the real world, from beans growing beneath solar panels at sites like Jack's Solar Garden in Colorado, to livestock grazing under arrays in New York, and native habitat and pollinator plantings around solar installations. Researchers also work with partners from universities and projects across the country to understand how solar designs can best support both agriculture and energy production.